Hello everybody, this is Group 4 from Junior Design 2, Spring 2010. This is me, Hassan, and my partner Martin. He's making video right now. We were working on a project called Automated Temperature Control System. Looks like something like this, which you also can call a microprocessor cooler. Now, we have it assembled on a PCB Gita and it's done here. We ordered it online. And you can see some of the parts. It has the power jack here, microcontroller here. Our voltage regulator was kind of broke, so we used the jumper wires, USB-B to connect it to the computer, a programming header, and a fan that will look like this. Basically, our project is to sense temperature in a room, and then according to the conditions, turn on a fan, and it can go other way and turn off the fan. And then you would connect this USB to the port that we have already here, plug it in, power it from here, which is a power jack, and then it's plugged into the computer. Then the programming we have done for the GUI to test the temperature is you just play this button, the programming we have, and it comes out like something like this, which shows you the Celsius and Fahrenheit both scales. And right now it's currently showing you the seconds, and it gives you an estimate if it's connected. Right now it's disconnected, but if it's connected and working, it will show you the exact temperature of the room in Fahrenheit and Celsius.
Hello everyone. I'm just going to touch base a little bit on the problems and the troubleshooting we went through during this project. As you see, well, first of all, I'd like to say that the project unfortunately does not yet work. As you see over here, the initial issues we had is with the power going to the voltage regulator. Initially we thought that the voltage regulator right here was burned out, so we went and got another one. But after the other one was showing the same symptoms, we turned into thinking maybe the connection to it are wrong. So after trying a couple of regulators, and we noticed that when we solder them, that's when they start showing the symptoms of open circuit like we've been talking about. And so we decided on this kind of configuration, having those connected with jumper wires. This also didn't work, which led us to believe that probably some specification, some electrical specification on the microprocessor is not being met currently. We noticed on the VDDs had to be connected together, and this is what this wire is doing right now, is connecting the VDDs in one line. Unfortunately, that was not the issue either. We have to look at another issue of maybe a couple of pins on the side, the VSSDs, which are responsible for the digital domain of the chip. They also need to be connected together, and that's not been completed yet. Another thing I wanted to touch base about is that we did create the microcontroller instruction software through the PSOC creator. And we were able to program our demo board, compile and program our demo board every time we worked on that. And that worked out just fine. And we also developed a GUI that Hassan just displayed. But unfortunately we found out the hard way that the First Touch starter kit does not have USB connectivity, so that way we cannot figure out whether our the GUI is working properly right now. As Hassan showed earlier, this is again our GUI when it's working right now. I can show it's connected to time.windows.com now, so it's just giving you what the time is right now. But once these comments are removed, then the connection manager will try to read the temperature from our thermistor.